morning, students. Yesterday we discussed about how to establish the product architecture. How to establish the product architecture. And just I revise what I covered in the previous class. That is the steps involved in developing or in establishing the product architecture. Okay? Those are the first one, create a systematic schematic of the product. Okay, we need to create schematic of the product. The second, the cluster of the elements of the schematic. The third, create the rough geometric layout of the product. Fourth, identify the fundamental and incidental interactions between the building blocks or within the chunks of the product. So these 4 steps we discussed extensively in the previous class. Understand? So that is, we need to develop a geometric sketches with a 2-dimensional, okay, the rough components, all the components involved in developing a product in a schematic way or in the sketches on the graph. Okay, that layout is known as creation of the schematic of the product, of all the components of the product. Then we need to group them, or we need to cluster them depending upon the functionality of the components or the units or the building blocks of the product. That's the second step. Third, the rough geometry of the product, 2-dimensional, 3-dimensional, isometric, top view, front view, altogether. The last one is the fundamental, the interaction between each building blocks or the chunks. Okay, what are the incidental interactions, physical interactions are to be studied. Okay, then today there are some of the aspects which are related or which are affecting the product architecture. Okay, so you note down the points. Okay, so these are all the issues or the points to be considered while developing the product architecture. Okay, the first one is delayed differentiation. Delayed differentiation is the one of the concept which has to be taken into consideration while designing the product. Understand? Then second, platform planning. Second one, platform planning. Third one, related system level design issues. Related system level design issues. Okay, these 3 things we'll discuss today about the product architecture. Understand? The first one, you take first one, the delayed differentiation. When the firm offers several variants of the product architecture is the key determinant of the preference of the supply chain. Key determinant is the supply chain. Okay, when the firm or the industry or the organization offering several variants of the product, varieties of products. Okay, not only one product, varieties of product. Okay, the product architecture, okay, is the key determinant of the performance of the supply chain. Okay, the supply chain, as you know, and you're studying a subject on that. Okay, it is a sequence of procurement, production, manufacture, distribute. All these activities are linked from the supplier to the customers. So this will get affected. The supply chain performance gets affected because of the product architecture. Varieties of product architecture in the hand will affect the performance of the supply chain. Okay, so in what way the product architecture has to be taken care such that the performance of the supply chain is going to be improved. Okay, supply chain performance is going to be maximized is the challenging job for the PDD engineers. Okay, so in this context we use the concept called as delayed differentiation. Delayed differentiation. Imagine there are three different versions of printers have to be developed by the Hewlett Packard. Okay, with differential electrical power standards. Okay, so they are manufacturing three varieties of printers with a three different electrical power standards, and they are supplying to the three different regions or geographical areas, three different geographical areas. Okay, assume that some countries are very cold, some countries are very hot, some countries are medium environment, and their electrical standards are different. So the Indian electrical standards are different, and American standards, switches and power requirements are different. So in this context, the Hewlett Packard is manufacturing three different printers with the three different electrical power standard connections, and they are supplying these three printers for three different locations or the geographic locations. So this is a challenge for them, for the product architecture team, how best they can maximize the performance of the supply chain. They use a concept called as delayed differentiation, and also it is called as product postponement. It's also called as delayed differentiation or product postponement. Okay, you see the sketch 9.10, that is exhibit 9.10. The first scenario, you refer that book, the Woolrich book, PDD. The first sketch, scenario A, that tells you the three varieties are to be assembled, three printers are to be assembled with all three varieties of the different electrical power standards. Power conversion assembly has to be assembled along with the assembly of the three printers. And these three different printers have to be transported after assembling with all the components of the printer and being transported individual to the individual regions. So this is a traditional way of supply chain practice. So here the supply chain performance is very poor. Supply chain performance is very poor. Then you can ask me, sir, well, then how the performance of the supply chain being improved? The concept is the delayed differentiation or the product postponement. It is the only solution where we can maximize the performance of the supply chain profit. Okay, then refer figure or the scenario B in the 9.10 figure. See, the all components are being assembled. Okay, the product is ready except the power package, power conversion assembly. The product is differentiated with respect to the power conversion assembly. So that power conversion assembly we are not attaching to the assembly in the factory. What we do, without power conversion assembly, we prepare all the assemblies of the all three printers and we load it and we transport it and we keep the warehouse near to the suppliers, near to the supply, all three suppliers. Okay, the middle point is to be selected where the warehouse is being created. So in that warehouse, the all assemblies without power conversion assembly are being stored. Then, depending upon the demand at the each region or the zone, and depending upon their requirement, okay, three different zone, three different power conversion assemblies. Okay, assume that first zone required some 1,000 units of assemblies of the printers. So for that zone, the that power package conversion assembly is going to be done and it is going to be sent to them. Similarly, for the other zone, as per their requirement, power pack assembly is being done and distributed. So only the assembly of the power conversion package will be done in the warehouse and it is going to be dispatched. That is, the variety is expected at the end of the supply chain. So in the previous scenario, all the assembly, including power package, being done, it is being transported to the different zones. But in this case, only power package assembly is going to be done at the end of the supply chain. That is called as product postponement. And also I'll give an example. Okay, this is called as a product postponement philosophy. I'll give a better another example, and already I think I have been given. Okay, assume that. So the Maruti car manufacturers is going to offer around 100 colors. Assume that 100 colors of cars of one. Assume that one model. Okay, the Maruti Ciaz. Assume that Ciaz. The Maruti Ciaz is going to be given to a customer with 100 colors. Assume that. When the customer goes to the dealer and asking a particular color out of 100 colors, do you think that the dealer is supposed to keep all 100 colors, 100 Ciaz cars in the showroom? No. If it is a traditional way of offering colors of cars to the customer, 100 colors, definitely I need to keep all 100 colors if I am adopting the scenario 1 with respect to printer. Okay, so because it is a traditional way, everything should be, the assembly should be ready, complete, only it should be dispatched. That is the scenario 1. And it is not possible in the present day context because 100 Ciaz car keeping in one showroom, it is highly impractical. Okay, and it is not possible to satisfy the customer with 100 colors. To satisfy, we need to have a huge car storage warehouse. That is not possible. The investment is very huge because we don't know what customer comes with what color. To overcome this, I just keep 10 Ciaz cars with respect to scenario 2 where I explained about the printer. Okay, product postponement concept. Okay, I'm adopting. I keep 10 cars. Let the any 100 customers, let any customer comes with any of the color in 100. Any color, let him come. Okay, I will see that that color is to be provided to him. Just I'm keeping 100, just I'm keeping, instead of 100 cars, I'm keeping only 10 cars. And I can give, let the customer comes with any car, any color of the car. So what I do to do this is I postpone the painting of the car to the last point of the supply chain. That is nothing but till all unpainted 10 cars are being kept in the warehouse of the dealer. We don't know what customer comes with what color today. Let the customer come. If he wants a red color, I'll promise him that, yes sir, tomorrow you can come and take red color. Okay. Immediately I trigger, once I get the order, I trigger my painting shop and see that a car Ciaz is to be painted with a red color and tomorrow it's going to be dispatched. Okay, they assume that some person coming with tomorrow rainbow colors. For a Ciaz car, you want rainbow color. Yes, yes, I will give tomorrow, day after tomorrow. I can promise. So I will trigger my paint shop in the dealer that a rainbow color is to be printed on a Ciaz and I will deliver next day. So it is possible provided I am adopting product postponement concept in the supply chain. By keeping 10 cars, I am satisfying my customer any color in the 100 colors. So this is called as product postponement. It improves the supply chain performance. Okay. If with the scenario 10, if I'm keeping only 10 cars, 10 different colors, if the customer comes with the 11th color, we don't have car because it's already been painted. So this concept or philosophy is called as delayed differentiation, or it is called as the product postponement philosophy. So the product architecture has to see that to what extent the product can be postponed to have a better performance of the supply chain. It's also a challenging job of the PDD, product design architecture. Then comes to the in this case you need to note on the 2 points to have the product postponement. The first is that the differentiating elements of the product must be concentrated in one or few chunks. Okay, that differentiation what you are making at the end, so such that it should be available in a one chunk or one building block. It is going to be immediately fixed to the assembly. But that concept is to be adopted. Second one is that the product and the production process must be designed so that the differentiating chunk can be added to the product near the end of the supply chain. Okay, that is nothing but we need to push the final assembly to the end of the supply chain, as I gave the example of the 2 things of the product postponement car example like that. Okay, so well, now we discuss on what do you mean by platform planning. Okay, so as you know that the Hewlett Pack provides a desktop product to the customer with a different needs. Okay, for example, customers belonging to the 3 market segments. So one segment tells that family, another segment tells of students, and another segment is for small office or the home office. Okay, to serve these 3 customers, the Hewlett Packard could develop, okay, the possibility of developing. So okay, they can entirely, okay, they can develop 3 entirely different products, different products they can develop for 3 market segments, or they can offer only one product to all the market, or they could differentiate these products through differences in one subset of the printer component. So these are the 3 ways a Hewlett Packard can supply its printer to the 3 different segments in the market. Okay, so the desirable property for this product architecture is that enable the company to offer 2 or more products that are highly differentiated yet to share a substantial fraction of their component. That is nothing but in manufacturing, up to certain stage of the sub-assembly of the components has to be done on a single line. Those are all the common components or the common chunks which are expected in all the 3 models, and those models for different segments of the market. Up to certain point in the production line or the platform, production platform, okay, the design product architecture designer has to take care that the commonality of the components for all these products, 3 varieties of products, could be manufactured up to certain point. These are all the common components which are going to 3 assemblies. Then after that, they need to change the product lines. Three models, three lines with the minimal chunks, with the minimal differentiation. This is known as setting of the product platform planning. As a architecture, product architecture, I should decide, okay, to what extent commonality is to be done and to what extent the uncommonality, the differentiation could be achieved. Okay, that is known as the platform planning. Okay, platform planning to have or to maximize the design and manufacturing process. Okay, the commonality should be there up to certain point in the product platform. Then only we can maximize the design effort, and also we can get the manufacturing benefit. That is, we can manufacture with a low cost. Okay, this is most important. Okay. So to have this product planning platform, product planning platform, so we need to adopt two plans. Okay, two plans, or we need two types of we need two types of informations. One is differential plan we need, and commonality plan is needed. Differential plan and commonality plan. What is differential plan? Differentiation plan, no doubt, differentiation plan explicitly represents the way in which multiple versions of the product will be different from the perspective of the consumer and the market. Okay, this plan tells you in what way the product versions or the product varieties are different with respect to the customers and market. Okay, refer the figure 9.12. It tells that it tells the differentiation plan, and this plan consists of a matrix, and it consists of a rows for differentiating attributes of the printer. Rows consists of differentiating attributes, and the columns of the different versions are the models of the product. Okay, the column represents the different models of the product. So like this, we need to have a table. We need to create a table. Okay, the first column are differentiating attributes, and other three columns are the varieties. Okay, and what are the differences in the three models we need to highlight in the each table. So that table is called as differentiation plan. How each product varies from each other, that is going to be depicted in the table with reference to the differentiating attributes of the product. It is called as differentiation plan. The commonality plan, same way. The commonality plan also has got rows and columns, and the first column tells you what are the chunks have the common attributes, and the right hand side they are the different varieties or the segments. Okay, so what are the common chunks, or what are the common building blocks that occurs have to be put in this commonality plan in the rows and columns. So these are the two plans, differentiation plan and the commonality plans are required for product architecture to have a platform planning. Then we need to have a trade-off between the differentiation and commonality. So there are 3 points are to be considered for having the trade-off. The first one is platform planning decision should be informed by quantitative estimates of the cost and the revenue impacts. Okay, so the platform planning, okay, we should have an alternative platform. If we adopt this platform, what will be the investment and what will be the revenue? Similarly, if you adopt the second platform, what will be the estimate of cost of investment and revenue? So like this, we need to have different product planning platform, and in a group or in a cross-functional meeting, we need to arrive which platform is more beneficial, then that product planning platform has to be adopted for manufacturing the varieties of the products, and that platform is going to be taken into consideration by the product architects. Okay, then second, iterations is beneficial. Iterations is based on our experience. The teams and better decisions have to be made depending upon iterating. If you do this, what happens? If you do that, what happens? So like this, we need to iterate and finally conclude. That is to be adopted. And the product architecture dictates the nature of the trade-off between the differentiation and commonality. The product architecture, which is going to be designed by the product architecture, that determines the where the trade-off is more beneficial. These things to be considered. Then the last point of the product architecture is related system level design issues. Related system level design issues. The 4-step method, what we dictated in the previous class, they are being establishing the product architectures in the early system level design phases. Okay, those 4 steps have to be adopted in the early stages of the product development or the product system level design. But many more detailed activities still remain. That is, in the beginning we decided, that is called as the early stage, and after we design the product and which is expected to be completed, at that time we need to have an additional product architectures or additional components or additional chunks which are expected in the product architecture, and that cannot be decided in the early stages of the product architecture. So that's why we have 2 types of architecture. The one, we need to decide about the chunks and the building blocks which are expected at the early stages of the product level design, and there are some other chunks and some other additional functionalities or the chunks or the building blocks which are expected or which are expected to include at the end of the system level design. Finally, the product comes out as to meet the customer requirements in the market. So to have this, we need to adopt certain points have to be considered. One is defining the secondary system. So as told you that some of the chunks or the functionalities are to be added at the end of the system level design. So what are those? Those are called as the secondary systems. Okay, we need to identify which are the secondary systems which are going to be attached to the product at the end of the system level product architecture design. Then establish the architecture of the chunks. Okay, we need to the secondary chunks, secondary system chunks. Okay, that also we need to establish the architecture, chunks within the chunks. Okay, that also system level, as we did in the product architecture in the beginning. The same concept have to be adopted for secondary chunks or the secondary architecture for the chunks. Okay, the architecture also going to be established for secondary systems also. Then the third point is that we know that the interfacing. Okay, the interfacing is nothing but when the mechanical chunks interact with each other, so it evolves some heat, the heat dissipation, or when the mechanical component each chunk interact with some mechanical mechanisms, so they evolve vibration. So those are all called as the interface characteristics. So those interface characteristics. So those are also have to be clearly defined in the secondary system. Okay, so once we adopt these design issues in the before the product architecture and after the in the system level design, before the system level design and after the system level, and see that the primary systems and secondary systems have to be completely assembled at the final stage of the system level design. Okay, so this completes the product architecture. Okay, so note down the questions again. identify and discuss other parameters or factors apart from the steps of the product architecture. 4 steps of the product architecture to be considered in supply chain by product designing architects. Next question. What is delayed differentiation or product postponement? Explain with a neat block diagram taking example of printer or taking example of Maruti car. Second question. Next question. Third question. What is platform planning in product architecture? And explain what are the different plans are being used for platform planning. Next question. Identify the design issues which are expected to occur in the system level design. Explain. Okay, with this I'm going to complete the product architecture chapter in the 4th unit, and we move on to the another chapter in the 4th unit in the next class. Okay, you need to answer all the questions which have been given. Bye. Take care.